I would like to present the classifications 19 types of skin conditions by using convolutions neural networks. My name is Muhammad Faris bin Hamdani from Jabatan Kejuruteraan Elektrik Politeknik Mukah, Sarawak, Malaysia. So this research is more about how to create the model that can be classify the image skin disease into own categories. Convolutions neural network (CNN) is a vision computerization analysis that assists in understanding the deep learning model. This study is carried out through proposed method for machine learning file that can be used for classified skin diseases through the deep learning base. So on this model, we use the artificial intelligence to categorize the image into their own categories. The study will determine the positions, recall, and score of the model to classify the type of the skins into their own category. The focus is to generate the architecture.h5 type file that can be automated for the diagnosis of 18 common skin diseases and 1 normal skin by using data from public clinical image dataset and patient's information using deep learning and pretend B7 model. So this is the model that we use to get the training, to get the accuracy of model and the total loss when it trains by using TensorFlow. So this research will generate the .h5 file at the end of the developments. Skin diseases are a significant healthcare challenge in the medical industry, which is required accurate and timely diagnosis for effective classification and after treatment. Computer vision and machine learning techniques have shown a promising result in the classification object in past study by using convolution network. Some study which is they can categorize the pet such as dog, cats. They categorize into image which is the image have the cat or dog. So we try to implement that idea into the skin disease. So we have 19 type of skin diseases including the normal one. In this study, machine learning will classify the various types of skin diseases into 19 categories by using pre-trained model efficient B7s to measure the robustness accuracy for the model architecture at the end of the research. By using AI to classify skin diseases. So why we use that artificial intelligence to recognize or to classify the skin disease into their own category. The first one is a model can apply the hardware that can be running on GPU on TensorFlow for future AI development or robotic development. Humans use the vision to adapt and understanding their surrounding, but the computer vision works on duplicating human vision but in electronic form. To see and interpret an image, it must be given the ability to detect, identify, and process image in the same way that human vision does. So AI can do same like we, but they have some of consequence and limitation that we need to consider. So the model that we use is a Efficient B7 model towards skin classifications. Efficient B7 success in achieve high accuracy have made it a powerful tool for medical research and skin disease analysis, with ongoing advancement deep learning technique promising to contribute significantly to skin disease diagnosis and understanding. So this is the literature review. The strategy is to implement the best model that fit with the image classification by reviewing the past research. This is the first step we need to do lah. And next step is plan. Determine the best way to produce the pre-trained model and selected which one are the suite with the data collected. For example, in 2018, they have the computer vision and machine learning technique have shown promising result in the classification object in past study by using convolution neural networks. And the next year, 2019, the main idea of behind ActionNet is to provide a better accuracy and efficiency by scaling the model depth, width, and resolution. Instead of simply making model larger, the researcher introduced a compound scaling method that balances the three dimensions to find the optimal configuration. This is some research have been done before. So why we select the model ActionNet B7s in 2021 and 2022. A lot of researchers from first study are more focusing on ActionNet B7, which are the highest accuracy on previous study. So that means they have a lot of research about classification of skin, and in 2031 they find out the ActionNet B7 is the best model pretend model that can be used and implement into classifications object or skin disease or anything. So we try to do same as 2021 but with a lot of data skin disease. Methodology, data preparations. This methodology we use the image that we need to data preparation is the action of the gathering the data need to make more convenient and reasonable before feeding machine learning. Messaging it into format that computer readable and understandable and asking question of it, check it or for completeness and bias before loading image dataset and image file is folder that have already been categorized. On the left side, if you see the graph on the left side, that shows the categorized 90 type of skins that be rearranged in the folder with name, that type of skin image. At the left, the right one is an example of data structure or data frame series, which is they have been done implement the label into the image that will be used the next model in artificial intelligence. Data image augmentations. This before we feeding into the artificial intelligence trainings, we need to do some data image augmentation. This is the important part, which is the image will generate a lot of variants into the folder that can be applied in various type of transformation to the existing image, such as a rotations, flip, zoom, brightness and contrast and color. So if you see the first one is the image, the real image, and then the next one is the image, the same image, but they have the low contrast and brightness, then and the color jitter. So this is the data image that will provide into the model. Before we feed into the model, we need to provide this data. The goal is to improve the generalization and robustness of the machine learning model by using variant in input data. Data augmentation is suitable for limitation dataset that available to use, and it can be prevent overfitting and enhance the model ability. So the next part is a training model by using ActionNet B7s. The pretend model is used to features extractor, and its output will be used to input to custom the layer of the model. The layer of the model called dense, which is its connected layer with dropout area add to the model. Dropout is a technique avoid to overfitting on model architecture. The Adam optimizer was applied to the model because of the lot of advantages such as adaptive learning rate, efficiency, low memory, sparse gradients, well invariant to rescale, link, intuitive, hyperparameter, bias correction, and work well with no noise. The epoch is the iteration that we will use in the model we use the 1000 training iteration cycle, which is it take in 3 hours, 3 or 6 hours by using GPU RTX 5000. Training a pre-trained model. After we done the train the model, uh, we check the accuracy of measured fraction of the corrector predicted made by the model out to the total number of predictions. It common metric for binary and multi-class classification problems. So at the end of the research, we find out the model can be generate .h5 file, and we can check the accuracy and the total loss. We will see the result on the next page. Result analysis. The analysis, if we look on the graph, blue show a positions, brown as a recall, and green for F1 score. These data are generate the same accuracy but different in weighted average. So if you see on the graph, the accuracy is starting on 0.4. Meanwhile, the weightage average is difference when position below 0.4, but the recall is sustained and F1 score is lowest. So this we will show that the accuracy is starting on 0.4, which means 40% is accuracy for this model. Training validation accuracy. The value of accuracy training is much likely higher than validation accuracy data. The data prove that if the iteration of the epoch increasing will produce more position and accuracy on the model classification. The graph show the fluctuated on every step of epoch in training session caused by the low quality and unstable data image on each type of skin disease. If you see the graph shows the training accuracy is higher than validation accuracies, but the main focus is the validation accuracy, because the validation accuracy is the result when the model are training on the image that the model not faced before, and it will get the results which is that accuracy is suitable or not with image. So validation accuracy is the main focus for this research. Training validation loss. This is the feedback of validation loss graph decreasing per epoch iteration. This data proven that validations loss graph can be decreasing if the epoch training are increasing. The validation loss graph shows is the frequent drop towards 1000 iteration epoch cycles. So at the end of the total training, the test loss is 2.01932. This is the Convolution metric. The Convolution metric is the metric table that lists how many prediction classify model on the set of the test data met correctly and incorrectly. The entries of the metric show how many test sample there were overall and how many those were successful and wrongly identified by the models. The box with the dark blue color means that a lot of data predict on the same label type of skin. If you see, the one is the ants and rosacea photo, and the first column is X ants and rosacea photo also. So when meet each other in blue dark colors, that means all the image data photo are point to the same label versus predictions, which means they predict the true label on this image they not faced before. So this is the model. We can determine the dark blue, more a dark blue is a corrected So that's why this model have 40% accuracy. So this is the example of the sample of prediction image. If we see at the image, they have the predict a normal skins. The greens means true, and predict is the same categorized, which means if the image predict the normal skins, the true is normal skin, that is correct. But if the true is the systematic disease and predict is an aneurysal photo, that is the incorrect. This is the model at the end of the product. We can generate .hy that can be used in a lot of things in the medical industry. So this is a model that we use to compare the image into the categorized labels. So if the prediction and true label are same, that means it the correct. If the true label and prediction is not same, this means is incorrect, which means the red color is incorrect, green color is the correct. So the model can predict the skin image by using the image that we compare to the system. Conclusion. In the conclusions, the exploration of version B7 for skin disease classification has revealed a validation accuracy of 40%, indicate both challenge and promising opportunity for enhancing the model performance. While the current accuracy may seem modest, it serves a crucial starting point for further refinement. This initial assessment underscore that important address key considering include data quality and quantity data augmentation, pre-processing hyperparameter tuning, continuous evaluations and iteration of model interpretable. So at the end of the research, we can determine that the quality of data is very important before we feed to the training model, because when the data is a more high quality and the image can focus on the subject matter that we want, that means the at the end of the model we can get the high accuracy by using this uh, convolution neural networks. So if there anything the audience wants to inquiries, we can contact on 017 and 690156. My name is Muhammad Faris. You can touch and ask anything about my research. Thank you.